I'll start with sharing my screen. I'm assuming you can see the screen.
Yes,
Um,
it's up.
okay, let me start with the genesis of this project. I was a K-12 teacher for 42 years, and for 28 of those years, I was also a college professor who worked part-time at a local college. And one of my jobs was to prepare teachers in a teacher education program to teach physical computing. And that kind of grew out in the early 1980s, prior to the PC, while Apple IIs and Atari 800s were available. And I was a big user of Atari 800 and started with Fig Fourth. So that's the genesis of this. And one of the things that we did was I started out as an industrial arts teacher and graduated from an industrial arts program. And we wanted to replace the basic electronics course because many people found it irrelevant or too complicated or whatever the case is. So we replaced the basic electronics course with a physical computing course. But of course, at that point in time, that mainly meant bit banging PCs, or in the case of the Atari 800, the joystick ports, in order to turn lights on and off, run stepper motors, et cetera, et cetera. So that's the genesis of this. But 45 years later, I guess, I started with Fig Fourth and kept that in my repertoire of teaching elements that I used over the years and became much more sophisticated, to the point that at one point in teaching the physical computing course, we had used Leo Brody's book, Starting Forth, as our textbook. So that was quite an accomplishment in my mind, mainly because I had to convince the people around me that that was an essential part of it. So along those years, and of course, many years later, I have kept this idea that I wanted to create a device, a universal device for kids, K to 12 kids and early experimenters and adults and hobbyists and so forth, an easy way to interact with the physical world and kind of use Forth as the basis for this project. So I came up with this idea of STEM stacks and STEM cubes. And what STEM stacks is a Blockly based, and if you're not familiar with Blockly, it was a project that came out of MIT, connected with oh shoot. Anyway, and I'll show you that in a moment. It's a visual based programming, and what I did was link that to the ESP32 Fourth that Brad Nelson had developed, or along with Dr. Ting, emerging from E4th, as we know, and using that. So I developed a device that is based on the ESP 32S3, and earlier in just the ESP32, but I found the S3 to be very accommodating. So what I did was I developed a functional prototype of the program, and I found a really great TypeScript and Blockly programmer to help me, whose name is Morali, and I believe he is on this meeting and should be hearing this, and just to let him know that I'm very grateful. Never met him personally, but we certainly meet online every week, and find him just sincerely helpful, and really made this project move forward. So let me get out of this. Don't mind if I get confused. I'm normally using Teams, but anyway, this was my original prototype of the program I'm using. And let me see, am I moving that out of the way for you? Is that better? So basically what it is this is the STEM cube, these are the STEM stacks. And this was my original functional prototype that I had presented to Morale. And basically, the idea is that you have a set of devices that you take, you attach, and they become part of this device on the right. So he had taken this and certainly made it look a lot better, and now it looks like this. So this is for K to 12 students. I'll clear this out. And there's two phases of this. There's the design phase and there's the build phase. So in the design phase, there are, and I'll bring that up right here. There are 5 ports that are on the bottom of the device I made and designed. And this is what the internals of that essentially look like, along with a screen that I attached to it. So this is based on the ESP32S3 and running ESP32 fourth. So like I said, there's the 5 ports that are on here, kind of represented by those images on the top, because they're RJ45 ports. It's a touch screen, and basically that's about it. There's an on and off button, an SD card slot, and a power supply input, and of course a USB serial connection on it. So with those 5 functional RJ45 connectors, we can take different devices like a temperature sensor, DC motor, OLED display, a stepper motor, and maybe a slide switch. And we can build them, and we start the build on the right-hand side here, our STEM cube. All right, so I'm going to take you through a very simple programming exercise in utilizing this. And the intent of this is to kind of teach fourth in the background, but have a successful experience for students that have not done any type of maybe computing other than playing games, but computing, or most certainly physical computing. So I'm going to clear this out, and we're going to start with a simple LED array. And I'll show you that. That LED array is right here. It's simply 4 LEDs connected to the port, and I'm making it Lego based in the sense that we could use a Lego backboard as a way to hold the devices. But there is a slew of devices that we can attach, as I was talking about before. I have a moisture sensor, the slide switches that we talked about, temperature sensor, which I'll be demonstrating, but a temperature sensor with a onboard and a remote sensing sensor. Let's see what else. Rotary encoder to put in information and move maybe possibly things on the screen around. Lego motor driver that plugs in nicely with off-the-shelf Lego motors in order to drive them. And there's others like a stepper motor driver, another DC motor driver for loose DC motors, and so forth. So we have that here. So once we have the basic idea, okay, we want to use the LED array, we can go over to the build. And now when we come over to the build section of it, the gadgets that appear here are based upon the gadgets that are selected. So we have 2 different things. We have gadgets, and the other ones are called widgets, and I'll demonstrate that as well. But a gadget is a physical device. A widget is a screen device. So if you notice, when I put that widget there and I take it away, a button appears on the, I got to click away. The button appears on the TFT screen, or the LCD screen. So for this moment, I'll take that away, throw it away, and we'll go back to the build. So now when I come over to gadgets, oop, what happened here? Did I undo a port? Let me, when in doubt, restart, right? There we go. So this simple word, and you see the fourth word that's created over here. So all the fourth will show up on the bottom there. So this takes actually 0, puts it in port 2 because we have our LED array in port 2. And it's going to take whatever bits I set with the binary number and send it to port 2, and LED or right LED array turns on them. So I'm going to do something. I don't know if uh, you people are aware of Knight Rider, which was a TV show back in the, oh geez, probably the 80s. But this was a common project I did on physical computing, or with physical computing, that many of the students understood and appreciated back then. But what I'm going to do is set up a series of LED lights that will light up in sequence. Give me a moment. Oh. Okay, and then we have some defining words. Not all the words are defined yet. This is still in prototype production. Still looking at what are all the minimal words I need in order to have a successful programming experience. But we do have some things like, oops, delays. Don't mind me. I'm not always good at this. Kids are much better. Okay, so essentially what we're doing, as you see, is we take the LED that we want lit and send it out to port 2, have a delay of 100 milliseconds, and continue on to the full sequence of lighting up each of the LED lights. And if you see over here, what's created is the fourth interpretation of that, which is the word called main, and it'll keep running until stop check. And stop check is just actually a carriage return that's in there. So what I'll do is I'll connect to my device, and this is all done on the web. There's no installed program per se. It uses something called Web Serial, if you're familiar with that, which I'm sure many of you are. It's supported by Google browsers, and I think Safari, and since the the Microsoft one is based on Google as well, it'll work there. So once we have this, the ESP32S3 is connected, and I can well, actually, there's probably nothing to see there at this point, but I'm going to send it. So now it's sent it to the STEM cube, and I simply run this, and it'll run. And let me see. There you go. So there's the sequence. Now that could be plugged in any one of those 4 ports. I chose port 2. But if you notice also here, what I have connected is a 4-button hardware button device. So now what I'm going to do is go back, stop this. I'm going to reset the cube, and I'm going to go back to this one and pick out that 4-button set. So now I have a hardware set of 4 buttons and the LED array. And another thing, along with the emphasis of fourth, or in the frame of fourth, is that we can create a dictionary. And in our dictionary, I could take this word or the set of words that I use together and build my new word. And I'm going to call this array. All right. So now I have created a word in my dictionary along with the lines of forth that array is there, and I can come to pick up from that dictionary my word now array. And the code that's generated is essentially the same. The word here, of course, is created, and then we utilize it in place of all this text inside the main, begin, and so forth. Now, there's also the idea of compare. So under control words, now, I was playing with this last night, and I think I have some logic backwards, so please bear with me. Um, so in the widget area, there's something called from and to. So I can get information from a widget, or I can send information to a widget. In our case, we're talking about a button, so we want to get information from. So it's an input. No, I'm sorry. I'm doing the wrong thing. Here it is. I need to read that button. That's a gadget. So I'm going to read the button that's on PB1. All right. I'm sorry, port 1, that's here. And I'm going to read button PB1. And if we go over here, there's 4 buttons, PB1, PB2, PB3, and PB4. So I go over to the build, and so I read this button, and I say, okay, if it's true, run the blinking. There's a word in here, or I'm sorry, uh, a block in here that we could use. And I'm just going to put in some manual code because I haven't created the word or the block for it yet. But in nip ports, and essentially what that does is shut all the ports off. So it stops the blinking and clears out the IO control and so forth. But again, if you come down here, this is the array that I created. That's pretty straightforward. It's going to take a binary number, put it out port 2, and write to the LED all the way down to each of them. And on this one, it's going to read the button, and if it is 0, and this is where my logic is backwards. I think I was writing this late last night. Then it's going to run then it's going to run the array. So on. It goes read the button. If it's true, do this, else do this, then move on. All right. So we'll send this to, and I like to switch to the terminal so I can see if it in fact all went there. And I can turn this on now, and so very simply, I hope, there you go. You push the button and the LED array functions. All right, so that kind of demonstrates that. It has the ability to export, so I could save this, and it saves it as a JSON file. I could save this, and I'll do that just for the sake of the demonstration, and then of course I can import that back in again, and it all comes back and ready to go and connect it. So I'll reset that. And so the next demonstration I want to show you is utilizing a temperature gauge. So what I'm going to do is go back to the design. I'm going to put the temperature sensor on there, and I'm going to utilize say the brick motor. Now, this goes back to how I would use this in the classroom. And this might be a design brief that we would give a middle school student, or even earlier, and definitely later in high school. But the design brief is design and build a StemStack project that measures and indicates both indoor and outdoor temperature in real time. So that would be, there would be some initial instruction about temperature, what temperature means, how a sensor can detect temperature, humidity, et cetera, and how these things can all work. So there's an advanced organizer that's presented in order to get the students focused on the job at hand and making a solution to that design brief. So I'll move on to this. Now since we got a temperature sensor and a brick motor, I can come over here. Now my gadgets that are available are read a temperature. Oh, you know what? Let me back up. I meant to go with this intermediate step. So I'm going to do this project where I introduce a widget on the screen, and you see I put a meter in there. I made it an extra large meter, which means it fills up the screen. And since I'm measuring temperature, I want to go from about 15 degrees, about, oops, 15 degrees, 15 degrees. I'm doing this in Celsius or centigrade to about, let's say 35 degrees. And this starts to create my meter that from the minimum to the maximum, and then the quadrants that I want to show on the screen. So I'm going to break them into 5-degree quadrants, 15, 20, 25, 30, and 35. Okay, so there's our setup. And oh, you know what? I never stopped this over here. Okay. All right, so now I have my temperature sensor, which is connected to port one. I could read on board or the probe, or I could go back a little, make it a little more sophisticated. I could duplicate the meter, call this meter two, okay, and then move that. Let's see. I can move that on the screen to be positioned. So now I have two screen images of 2 meters. And then I go back to build and I could duplicate this and I could read one on board and one by probe. All right. So now this is where I was before that I made a mistake. I want to read the temperature and send it to a widget. Widget is the screen widget. So I'm going to send it to widget and I duplicate that. So now I can send the onboard temperature coming in port one to meter one, and I can set the probe temperature coming in P1 because there's two temperature sensors on that particular device, and I can send it to there. And now what I'll do just for the sake of doing it is I'll put a slight delay in between each one and give it a little time to read. So now we have the essence of our project. I will now uh, send that to it. And I got to change the brightness of this camera. I'm using an old phone as the camera because you can't see. There we go. So if you see that, there's the 2 meters that are now created on the screen. And what I haven't done is plugged in the temperature sensor. Let me do that. Okay, so now we have our temperature sensor. And I know it's a little dark, but at least you see the screen part of it. And then I can go over here and run it. All right, and we start to see our 2 temperature readings. And if you notice, I'll put my finger on the onboard sensor and that starts to climb. I hope. Maybe I'm cold. There we go. And then I'll grab the probe sensor, and that's a little more dense. So it takes a little while for the heat to get in there, but you start to see that it does climb little by little, maybe squeeze it a little more. There we go. So very easily, kids could create a device that they could use permanently in order to do an exercise that measures temperature. And along with those design briefs that I was showing you before, some of the other design briefs that go in is design and build a StemStack project that uses temperature sensors and moisture probe in order to maintain the temperature and humidity and maybe the wetness of the soil in order to um, grow plants. And then another one might be, okay, it gets too hot in a greenhouse. How might we add a cooling fan and measure the temperature in the greenhouse and maintain it at a very specific temperature that is best for growing? So they're the two elements. There's some others here that I have, temperature controlled fan, training, spot the dog with sound, and so on and so forth. But very easily, this could be implemented by a relatively young student who, third, fourth grader, simply by interfacing forth with Blockly and getting them to learn the nomenclature and the vocabulary for both programming and also talking about the physical world in terms of sensing and movement and so forth. So let me reset this. Oh, let me stop this. Okay. Reset this. And I'll bring in some other programs that are already pre-written. So I'll bring in this one. Okay. So this now is a demonstration that uses a temperature sensor, DC motor, and a fan. And in essence, I created a word on my dictionary that says read on board. It's going to read the temperature on board. I got something missing here. Yeah, I don't know what I got. Something's not right here. Let me just get that out of there. So it's going to read the temperature of the onboard sensor, compare it to, I had this big debate whether I use floating point or fixed point. I ended up, because the temperature sensor, because of its nature and the way it works, it's a Dallas single wire device. It reports back in, at least through the library, uh, in decimal points. So what I did was I multiplied that in order to bring it out of decimal point and bring it to fixed point to go along more closely with the digital aspects of buttons being pushed and analog readings and so forth. So anyway, so the situation here, it's going to read the onboard, so it'll go out, use this word I created, compare it to 2700, which is 27 degrees centigrade, determine that it's greater or less than, and then decide on whether it runs the motor that's in port 2, whether it runs that motor, in this case, motor A. It could have two motors. It could go clockwise, counterclockwise, or as some say, clockwise or anti-clockwise, or it can be off. And that, of course, is connected to port 2. So we have our sensor in our port. And then if that doesn't meet that requirement, then it's going to set the motor and turn it off. All right. So let me just get rid of this. I don't know how that got there. But anyway, so I do have the motor. But what I'm going to do for the sake of the demonstration, because it's easier to see, is I'm going to plug back in that LED array, because what that does is indicate one of the 4 bits that are turned on that drives a bidirectional driver chip in order to a bridge in order to turn that motor clockwise, anti-clockwise, or off. So I'll go back now and I'll reset. I'll send that information of my program, which is the code here, So it builds the meter. I didn't show you that before. It builds the meter using build does or create does in Forth. It reads the onboard temperature, fetches that, and then it runs the program comparing it to that 2700. So I'm going to go to the terminal, send that to it, and we're going to start running it. All right, so now it's running. And I don't have the meter attached. But I did design it in the builder, I mean, in the designer. So what's going to happen is it should, if everything is right, and let's see what's going on. I'm not getting, did I say on board? Yeah. Ah, good chance to debug here. I'm going to stop that. I'm going to add that meter into the system. By That's what this was. Okay, so now it's a little bit different. We're going to read the onboard, display it on the meter, read it again, and then go through our sequence of verifying or checking to see if it's over the temperature or not. And this will prove to me whether I'm reading the meter correctly or not, which something's weird here. So let's see what we got. Okay, so we are getting a reading, but I'm not getting a temperature reading. Let's see, do I have the wrong one? It's in device one. Oh, there we go. All right. And when it hits the, oops, sorry. All right. When it hits the 27 degrees, the motor will turn on, and I'm just indicating that with the LED array because I really don't have anything attached to the motor to show that it's spinning. And as it cools down, it goes off. So as it warms up again, when I touch it with my thumb and it cools down, it goes off. So another indication of something that's, pretty straightforward, understandable, and easy for kids to be successful at. My goal would be, after this is completed, let me just make sure we're still connected there. So my goal would be after students start to use this, that they forego the Blockly and start programming directly in Forth. Once they begin to understand the essence of it and can read in parallel what they're doing in Blockly in order to show this. So maybe I got one more demonstration. Oh yeah, this one. This is a real interesting one. I got two devices connected, two gadgets. One is the push button. So I'm going to reconnect the push button. I'll show you that in a moment. All right, so I'm reconnecting the push button in port one, and I'm taking out the other device and putting in a small speaker. And this is simply a small speaker driven by a NPN transistor that's in there. So if I go back and look at my design, I have the buttons there and I have a speaker there. And I have a set of words that I can create a song. And this, between Brad Nelson and Mark Peterman, I've learned a lot. The Great Book of Forth, of course, has helped me immeasurably in achieving some of the things that I thought would be extremely difficult, but that book, along with all the other things that are out there, put me on a path in order to achieve what my goal was. So we take a look at this. This is, I have created a song. I can call that song anything I want. I am not a musician, so all I did was throw a bunch of notes together and I pick up that song. And when I look at when I look at the code, uh, I just messed it up. I hit a, all right, I think we're back on track. We look back at the code. Basically, what it does is you create a song called Hello, plays all those notes using the LEDC right tone function that's in the ESP32 library, Arduino library, and work through with the ESP32 fourth. Um, and it'll go on and play that song. So I'll switch over to the terminal, clear it out so we could see it clearly, send it. And I still have an issue with this one, and it's very weird. I was working on it late last night, and still there's a bug in this, but it functions. So I'll just demonstrate it, and then we could start. So there you go. There's my big musical debut. Um, and then I
We
believe
can't
I
hear
had
the
one.
audio.
Oh, you did not hear the audio? Oh, you know what? It's probably
Yeah, we didn't
because,
see the screen or the physical.
say that one more time.
Oh, we didn't. I don't know whether you tried to switch to the physical stuff. We've still got the screen of the layout. No.
All right, let me go to audio. Ah, I see why. Okay. Um, let's try this. I went and switched the speaker. Come on back. Here we go. Okay, you're saying you didn't hear that, but you can hear me, right?
Yeah.
Okay,
Correct.
let me, that's all right. Let me go back and I'll hold this up closer to the, any luck there? No, huh? Maybe it's my earpiece. I thought I was using the other. No luck?
There is no audio problem.
I wonder if it's getting filtered somehow. There's some settings when you share, but you're just on speaker though, so that's weird.
Yeah, no, very odd. But anyway, I can tell you
Yeah,
it's
your
playing it.
voice is fine.
Yeah, the voice is fine. Now I'm using my camera, my face camera as let me try the other.
If you go to audio settings, there's an option for original sound because I think the default is it filters background noise. Maybe that's
Yeah, that'll be the problem.
Okay. Is it here?
Too smart for its own good.
it's under. If you go click on the little up arrow next to audio, and then there's the very bottom option, audio settings, and then there's an audio profile.
Background noise removal. Yep.
Probably want the original.
Yeah, I can't unclick. I could go to low. Now let me try that.
Yeah, that's it.
There we go. Aha.
Lovely tune.
Oh,
A
very
maestro.
interesting. Hold it. Now I can't get my earpiece back in. All right. So that's that's interesting. I wouldn't have anticipated that. Um, now I could probably go back to.
This. Let me try it just one more time, just for the heck of it.
Oh, now it's good.
Okay, thank you, Brad. Appreciate it. And I want to, just while I got you, appreciate all the work you did on the ESP32 fourth. I love it. Anyway, it made this project possible. And I've been thinking about this kind of concept for a long, long, long time.
What you've done with it here is tremendous. It's very impressive.
Thank you. Thank you. It keeps me up late at night, let's put it that way. And I know many of us have projects that are in that realm, and that's why we're here. So let me try one more thing. There's some issues that I got to deal with, as you can figure. And like I said, Morale, if you're online, speak up and introduce yourself. But if you're looking for somebody who can program in TypeScript and certainly Blockly, he's the person to do it. So let me import. I guess that's about it. I think I pretty much covered all the essence of it. I think the big takeaway is that in a structured learning environment, that all the precursors, like all the elements of engineering, electronics, mathematics, science, would all be incorporated into the concept of physical computing. So the physical computing is the center focus, and all the other elements can be taught to that, hopefully leveraging the interest of the students in whatever they're interested in. And as you see, we can kind of pull in music, we can pull in physical science, we can pull in chemistry, there could be pH probes, there could be, one of the projects I want to do with this is measure the time it takes for a ball to drop, to measure the speed of gravity on a falling object, and that could be done in real time. And one of the elements that I think about, or one of the uses of this I think about, is a universal device that would be used throughout a school. So a science teacher who needs a temperature probe can easily, or the students can easily program this to be a temperature probe. And they're doing this an experiment in science. It may be where they're measuring the temperature of freezing water and the temperature of boiling water. They could actually have two probes, measure both of them at the same time, and display them on the screen. Let me see. Can never get back to. Let me do this, and then that'll stop that. The other thing might be where again, a science teacher or whatever might be wanting to measure the pH, and now they have a meter to do the pH, or they want to prove the speed of a falling object. They got this. So it wouldn't always be used in a computing engineering environment. It also could be used throughout the school in different kinds of activities and be programmed to be a universal device that can sense and control the real world or the physical world. Anyway, let me finish off with this, and I know I'm sure I'm over my time. Always lose these buttons. Go back to this. And, I want to pick out some of the people who, even though I may not know them, and I certainly didn't know Dr. Ting, although I did meet Chuck Moore on this very forum a month or two, whatever it was, 2 months ago, maybe 4 months ago. But I want to thank those people for inspiring me to move forward on this. And also, if you're interested in contacting me, have suggestions, have questions, please feel free to email me. I'd be happy to respond to you. And again, if you're looking for somebody who can really program, for PC and web development, Morale with his TypeScript and Blockly. So there we are. Any questions? No. You guys can hear me?
Just really interesting. Yeah, thanks for the presentation. It's great.
Very impressive stuff.
Good. Any thoughts of what I could do to make it more sensible?
Is this available on GitHub or somewhere?
Not yet, mainly because we're still building the code. I have a GitHub site, but it's private at this point, only because we're, right smack in the middle of it. And I would not want to put it out with all I know there's bugs in there. My one goal with the physical device is to crowdsource it somehow. And one company or one group that I look at and I often buy things from is Crowd Supply, and they seem to be a very fair and equitable means of getting open source hardware out there for people to use. And I have thought about, I forget the exact name of it. Was it One Laptop for All? But do you remember the One Laptop project? One of my goals is if there was a way, if there was a way or a means that if someone, a hobbyist, were to buy one of these, that somehow one of these would be given to a school of their choice. That type of thing to start to get it out there. In my local educational development arena in the state of New Jersey in the United States, we have the International Technology Engineering and Education Association. And with our New Jersey hub, I give demonstrations on this and get support back and mainly feedback about how it could be realistically used in the K-12 classroom. And having had that experience myself, I have a good base, but of course I'm now retired, so I still need that connection and they're providing it. That's it. Rob, you in charge? Or Cornelius?
That's just a great
Yes.
architecture. I love the architecture of being able to see the code right beside the Blockly, plus the plug and play. It just makes it so simple to use. It's an extraordinary idea. Thank you.
Beautiful.
Thank you.
I've looked into these concepts, but this is quite frankly the first time that I feel motivated to look again. So that the time when I looked last time, which was the first time, isn't also automatically the last time.
Got it. Yeah, no, that's good. That's good. Yeah.
And it's
Yeah,
love it. It's cool.
One of the difficult things was deciding on how to create the interface so that multiple types of protocols and physical connections could work, right? So in the simplest form, there's 20 I/O lines, 18 of them because of the limitation of the ESP32 S3 in this case. The last couple don't kind of want to comply, but at least 18 of the 20 I'm using for those 5 I/O ports can be programmed, and it took me quite a while, but by using a combination of libraries and bit banging, I was able to make each of those ports capable of doing SPI, doing I2C, doing Dallas single wire or one wire, and then basic I/O, analog read, and analog output. So through that, I think I've been able to make it somewhat universal in the sense that you could take any device that at least is available now and moderately or cheaply priced and plug it in here and call a driver up in order to talk to it in that specific port, utilizing the Blockly as the selection mechanism. And so far, I've been able to achieve pretty much all I desired. I did some early experiments, but this is, Rob, you were talking about whether it's available on GitHub yet. There are other things I want to add, like the optical or the rotary encoder. It's a mechanical encoder, but in order to create the interrupts, detect the movement, and keep track of the position. Not impossible, but I just haven't fully done it yet or implemented it yet. I have light sensors. As a matter of fact, one of the boards I created on the sensors has 2 light sensors separated by a flag, so that it could actually be connected to a servo motor and rotated in order to find the brightest spot in the room or follow the sun, and we could start talking about solar collectors and their positioning and so forth. So there's a whole host of things that can be done with this simply by plugging in my mind anyway, by plugging in 4 or 5 different devices, programming them all together, and now you got a functional unit. One of the ultimate goals of this, and I'll stop after this, one of the ultimate goals of this would be to design a small board that doesn't have a touch screen on it. I didn't even demonstrate the touch screen, so I apologize for that, but it's capable of reading buttons and sliders and so forth on the touch screen. But a little device that would be cheap enough for a student to buy or to be given with a sensor or 2 that they could program this, copy that program into this standalone device and leave it as a standalone device. So if they did design a greenhouse that needed to be temperature regulated with a fan, it would be cheap enough to program it here, get all the bugs worked out, program this device, plug in the 2 sensors, and there you would go. And that's it.
Thank you very much. Thank you very much, Frank. Please keep us posted on the Facebook. As soon as you've got something on GitHub, I'm sure people would love to help and love to hear about your project. There's lots to do. Thank you very much. Thank you to Frank, everybody. Thanks for that presentation.
Thank you. Appreciate it.
So we've got